And today, I have my pleasure to have Franck with me. Franck probably needs no introduction for those of you who are following Yugabyte, but nevertheless, we'll let Franck introduce himself. So Franck, take it away.
Yeah, so I'm developer advocate here, and today I will talk about indexes, and that's a topic that may look simple, especially for people coming from SQL databases, but people coming from NoSQL databases know that besides the primary key, it's not always easy to have consistency and performance and all at the same time.
Awesome. So Franck, I think indexes are so basic in databases, at least in relational databases, as you say, and the lack of them makes life difficult for many NoSQL database developers. So I think it's fair to say everybody knows what indexes are, so we probably don't need slides to explain that. So maybe we just jump straight into a demo and just talk about stuff. It's always more fun talking about stuff.
So you see my screen?
Yes, I do. Can you make the font bigger?
Yes.
I mean, it does seem okay, but I just still always prefer a couple of sizes bigger if it doesn't mess everything up for you.
No, this should be fine. I just have to lift MX and reconnect, and that's fine. Yeah.
Yeah, that's great. Okay. So, all right. So let's get started, right? So I guess at the highest level, index just makes your queries faster. Very simple thing. You need to look up by a column, you go after the index. But what do you got for us?
So we will create a few indexes to see how they can address the performance issues that we may have. So I'm connected to a 3 nodes cluster, just a lab, and I have a small table. I like to do demos on small tables because it's easier to understand exactly what happens. The goal is to understand. And so a small table with a list of countries. And I have nearly 200 countries there. We have a look at the information there. Country ID is the primary key. We have a country code, we have names, and we have other information. And I will start with the first query. So on the primary key, everything is easy. We already had sessions about the sharding, hashing. So going to a row by primary key is quite easy. And now I will query on a column the country code where I have no index for the moment. So I get 1 row for CH, which is Switzerland, where I'm living. And I will run queries. I will show the execution plan because we need to understand how the indexes are used. And I will also show some statistics to really understand the performance complexity behind that. Better than looking at the time, performance is better. So each time I will reset the statistics. The statistics, those metrics are exposed in the HTTP endpoint with JSON, but I just query them from SQL because we can do that with a copy. So if I explain
one thing I'm curious about, Franck, like just for the audience, how do you query a JSON endpoint from SQL?
Yeah, I will show it at the end if we have the time. Okay. I use the copy command. The copy command can read files or run a program. And here I don't even run curl because I want to be sure that to be able to do it on any system. So I use bash and awk to format it. And I get it as a JSON. And Postgres, the query layer that we use, has all functions to do anything on JSON. I store it in table, and my function just do the difference between the cumulative values.
That's fascinating, actually. But yeah, we'll look at it at the end. Yeah.
And we have a lot of metrics. I'm interested in 2 main ones, the 6 and the next. In the RocksDB, our storage is based on RocksDB, and the tables are sharded, same for the indexes into RocksDB, and we will see that. So running this query, this simple query querying for a specific country in my countries table without an index does a sequential scan. There is no option for that. In the execution plan, we can see the inefficiency of it because it returns 1 row, but it had to read all rows and discard 195. So that were read for no reason, discarded by the query layer. And the statistics showed me that I touched the 3 tablets. I have 3 tablets on each node. So country is my table. Those are the nodes and those are the tablets. And for each, there is one tick going at the beginning of the tablet and then next to read the next values. And values there are column value. I have nearly 200 rows. I have 10 columns there that we can see also in the execution plan. So 210 columns, about 2000 of next reading. So we need to build an index for that if we want better performance for this kind of query. And I will create an index, simple index on the table for country code. So that's the simplest index we can think of. And I will run exactly the same query. So I reset my statistics. I'll show the execution plan for it and the statistics. And first in the execution plan, I can verify that my index is used. This is the index I've created. And now I don't have those rows removed later. The role predicate, the role filtering has been done as an index condition, which means that the index was used to filter this exact row. And I can see that in the statistics, this is one tablet for my index. The index is also distributed many tablets, but for one value, I need only to go to one tablet from the hash value of it. And one tick to go into this index at the right place for this value. And from the index, we read nearly nothing, just the primary key to go to the table there. And there it goes to the table at the specific place with the primary key, and then reads 10 values because I select 10 columns. So that's very simple. And this is already optimal in the sense where I get directly one row with the fastest path with reading from 2 tablets. That can be in different nodes, but we will see that we can optimize further if we need more performance for that.
Now, one question, right? At a higher level, when you are looking up this query against the index, does it serve it directly from the index, or is there another read that goes to the primary table?
Yeah, exactly. There is one read from the index there, and then it has to go to the table. That can be on the different node. We have also option to group things, but by default, the goal is to distribute, and then it can go. And so it adds latency, especially if those nodes are distant. Yeah.
So this is a distributed execution, right? So you go to the index and then go to the primary. So one question that I often see come up from people that are new to distributed SQL, specifically from relational databases, is does this scale? Like, suppose I have a 100 node cluster, right? Is this going to get worse?
Yeah, that's interesting because first it is a distributed transaction. Even if we look only at one row, it is a distributed transaction, and it is like a join, like joining the index to the table. But the thing is that the complexity of it just depends on the structure. If I add more nodes, I will not have to go to different places. Reading one entry from the index and one row from the table will always have to read at 2 places, never more. So if it is distributed on 100 of nodes, I don't read more than that. Yeah, so we are limited by the structure only. And then we will see that we can put in more indexing stuff to do less. But yeah, it scales with that. And other sessions will read other values and will read other tablets. This is where we distribute the load.
Awesome. And I think Kurt had a question about, is this a primary key index? You didn't specify primary key when you created the index. This is a secondary index, right? This is not the primary index.
Exactly. Table and indexes are stored the same in tablets. And when we create a table, the table is stored in the primary key. So the primary key is on the country ID. but I query on country code. And this is where in SQL schemas, we often need consistent secondary indexes because we usually have more than one key. We have the primary key, maybe generated by a sequence, and we have some business keys where we need also an index. I didn't define it as unique. I should have defined it as unique because it's like a second key, but it's not the primary key. By primary key, you go only to the table tablets.
Okay, so one question that Marimutu has, an interesting one, is can you do select country code from countries where country code is CH?
Yeah, sure. I can do it now, but I think the question is something I wanted to show later, but we will show it now. Country code from countries where country code is CH. So yeah. Just if I just want to check that that the value is there, I will explain it. Just copy pasting that and that, and there we see that it is an index only scan. But I will show it later with that's exactly what I wanted to show later. I will query less columns there.
Yeah, this was exactly Marimutu's question, to see whether it goes to the primary key table, the primary table or not, which it doesn't.
Exactly, yeah. Because we can be happy with that, but we can do better. And usually you don't select star. Here I did a select star, but in the application you don't do a select star because you may add more columns later and you query just what you want. So in this example, I query only country code and the name. And if I look at the statistics for that, so the name is not in the index there. So here I have an index scan, but I will still go to the table. But this is where we can add a covering index. So here I create a new index. Probably this index will replace the other one, but for the demo, I just keep all the others to show also the consequence of having too many indexes. So here I create an index that is still on country code, and I add the name. I don't add the name in the key because in addition to that, I want to enforce the uniqueness because country codes are unique, and enforcing the uniqueness makes things consistent. I don't have to do that in the application. I know that it is unique. So I'm just adding more values into the index. And then in this case, the execution plan shows index only scan. And if we look at the statistics there, we do not even have to go to the table. And never, this is similar to Postgres because we use the Postgres query layer, but Postgres still has to go to the table because Postgres stores the visibility for the isolation of transaction. Postgres stores the visibility in the table. So in Postgres, even an index only scan has to read the table. Here we have the visibility in the index. We really read only this index. So one seek there and reading 3 values. That's the best we can do for this query. And yeah, especially in distributed database, we need to index not for all queries, but the critical queries where we want the best performance. We probably will have covering indexes on them. Yeah. And so for this kind of query, a point query with a few columns, that the best we can do, we just read from it. But we can have more complex queries. And here I'm querying a range. I want all country codes starting with C. And here, if I look at the execution plan, I don't even look at the statistics because from the execution plan, I see a sequential scan. So I know that I'm reading too much information that are filtered later. And for that, yeah. So that was a sequential scan. what if I force it to use the index? And we can do that with ints. Here, I'm forcing an index access to understand that that's something I do usually when I see the query planner comes from a plan that is not optimal. And I think I have an index. I check with ints. I force the index to understand why it was not chosen by the query planner. And here we have the answer, especially with the statistics. Even an index-only scan, in this case, reads from all index tablets. So it's similar to a sequential scan, but on the index. And the reason is that by default, when I've created the index, the first column by default is hashed, because the most common goal in a distributed database is to distribute the rows. When we have a range query, we want to have the range collocated, all the ones starting with C collocated. And this is where we will explicitly create the index, not with a hash. So I didn't mention it, but hash is the default for the first column. This is the index that have been created. And now I will create an index where I explicitly mention that I want a range, and I can even say the range is ascending or descending. And running exactly the same here. So that's very important for all columns where we know we will query on a range. For example, if you have a timestamp, probably you will not query equal timestamp. You will query on a range, and then you need to create the index specifically for range scans. And here I see that the execution plan is very similar, using the index, but reading only one tablet at one specific place. And I have 45 values here. The math is easy. I have 15 countries starting with C. And for all those 15, we have seen before that we have 3 reads, because it reads the value, the primary key, even if it's not needed there. And I query the name here in the output. So 15, three times, and 45.
Got it. Nice. So a bunch of questions.
Yeah.
So, let's go over them in order. First, Radek. Hi, Radek. Hope you're doing well. How are indexes stored? If I have a table with a table space constraint, is the index stored only on those nodes where the table resides?
So yeah, we can create table spaces with the same syntax as Postgres, and the goal of table spaces for Postgres is to put in specific file system. In Yugabyte, the goal is to put preferably in specific nodes, for example, specific region, to have the leader there. So same for the indexes. If I have a partition table, for example, I can put the index partition with the tables. If I want my query to go to the local region. And we have also, but I think we will have other sessions about that. We can also create multiple index on the same columns with the purpose to duplicate them in different regions, so that in any region where I connect, I can find my index entries in the closest region.
Yeah, fantastic. So awesome. Yeah, I think the takeaway there is treat indexes as internal replicated distributed tables, right? Like essentially that's the takeaway. And so whatever the constraints are that apply on a table, they apply on indexes, except you don't specify it explicitly, right? Sometimes you do, sometimes you don't, right? So because the database manages it for you. Okay, so Marimutu has another question, which is interesting, which is, can you add country ID to the query that you ran before? So what he's trying to understand is, are all the columns of the primary key implicitly stored in the index? I mean, the answer is yes, because that's how we locate the original row. But yeah, so.
Yeah, that's a very good question. And the answer is I don't know, because I remember opening a Git issue with that.
No, we do, because the primary key of the primary table, right? Its primary key determines the row, and the index points to the row through that, right? Is no? Okay.
Except that this is not an index-only scan. So in this case, we have all information in the index, so we should be able to get all information from the index, but the primary key is encoded in a different way. And today in current version, we still go to the table. If
I wonder if it is because this is a like query, right? Can we do an equality query?
Yeah, but it's the same. We have an open issue with that, yeah, it's something that will be fixed.
Got it. Yeah. So yeah, I think so, Marimutu. I think theoretically it should be possible. Looks like we have an issue.
Exactly, because we have the information. It's just encoded differently, and today we don't have the code that takes it from there. But all the information is there. Yeah.
Got it. And then Piet asked about is hash on the first column, so range scans will have to iterate. We already answered that. You can specify the index as a range index, and it's going to be efficient. So I think no need to. Yeah. No need, maybe is there more questions here? Just feel free. Yeah. Okay, and Kurt says you may want to point out that your support for hints and include column is an enhancement beyond plain vanilla PostgreSQL.
Yeah, exactly. PG plan is a Postgres extension, but we enable it by default because we need it in enterprise situation. I need it to understand the plan. Because, like I did, I want to try. That doesn't mean that I will put ints in all my production queries, but I need it to understand, to troubleshoot, and to work around also. The query planner, we are still improving it a lot to make it aware of the distribution, for example. And there are still cases where we need to work around with ints in some specific case until the query planner is ends. So yeah, we enable it by default. PG in plan, yeah.
Got it. And another great question from Sheikh, I didn't know this was the case, is that as per his understanding, when indexes are created in MongoDB, there will be a special memory allocated to store values to avoid sequential search. Is this the same behavior in YugabyteDB as well?
I don't know exactly even how it is stored now in MongoDB because it has changed. But indexes like tables are stored in LSM trees, and we have a first level that is a mem table. So for the tablet itself, there is memory. I didn't see the question. So,
is there special memory allocated? I think bottom line is nothing really special, I think, beyond whatever is allocated for a table. So when you create a table, what happens? Same thing happens when you create an index, which is like a little bit of space to do writes and like your regular cache, all of that. That depends on usage. But I don't think we allocate anything specific for indexes, right?
No. For the storage level, it's exactly like a table, just a different key. So yeah, but I will look at the MongoDB storage to understand better this question. Yeah.
Awesome. And Gopal had a question. Since we were talking about collocation, is there any way optimizer can identify how these index values are ordered in tablets? For example, if the table data is also ordered, like the index will be very efficient in range scans. If not, we'll be doing more block visits and more IOs.
So let me do the next query because I think it answers partially.
Yeah, he adds like something similar to clustering factor in Oracle, which I think you will understand.
Exactly. Yeah. So in Oracle, like in Postgres, you have heap tables and the primary key index is a secondary index. Here we store the table within the primary key. So there is no problem of clustering factor because it is clustered in the primary key. Like also SQL Server by default, like MySQL. But the thing I wanted to show about that, yes, the query planner knows when the storage returns the rows ordered. For example, here I'm running this query, country starting with C, and I can see that the result is ordered. And I know it because from the storage, it is ordered, but never do that. If you want a result order, you need to mention it in SQL, just to be sure, because in SQL, we have an independence between the logical view and the physical view. The DBA may add or remove indexes without any change in the application. So if we want an ordered result, doing an explain plan on it there, we need to do an order by. But the interesting thing here is the plan is exactly the same because the query planner knows that the output from this is already ordered and there is no need for an additional operation to order it. And that's the advantage of having an optimizer and a query planner. If I do an order by on another column, on the name, the query planner automatically knows that it has to sort it in addition to it. So this is a decision of the optimizer. In SQL, we just say, I want this ordered, and then the query planner will do the sort or not, depending on the existing structure. And I've created the index in ascending order, but I can also ask for descending order in the results. My ascending index can still be used with a scan backward, which is not as efficient as the forward scan, but still much better than a sequential scan or something like that. So I think this answers the question about, the query planner knows about the physical order and knows when it has to be ordered in addition to it or not.
Awesome. And another question from Hari, which is with multiple indexes that only differ by their table space, does the plan pick the index that's closest to the user?
Yeah, we have. So
a great set of questions. This is a great set of questions. I mean, this is awesome.
Yeah. That's perfect. And I mean, we can do the rest that was planned in another episode. Better to answer questions. I don't remember the name of the parameter, but we probably can see it there.
There's a geolocation costing locality?
Yeah. Always more difficult to find it when when we are talking, but yeah, this is the parameter and it is on by default. This is what I wanted to show. And yes, when we have indexes in different places because of different table spaces with mapped to the topology of the cluster, we have different costing for it to take the closest one. Yeah, so the query planner is aware about that. Yeah.
Awesome. I think we're almost at time. So maybe you have time for to show one more thing, Franck.
Yeah, the only thing one thing I wanted to show is that we can add more filters, of course, and more column, because an index on only one column is a simple case, and people tend to create many indexes on each column, and it's probably better to have composite indexes, indexes. For example, in this table, I have also the region ID, and if I want to query only for country code starting with C, but only in Europe, if I look at my execution plan with the existing indexes, I can see that I'm reading a lot there, but I can create an index with the region ID, and then it will be faster. And maybe if we have no question and 1 minute, I want to show something where we can come later, but that is really, really important. I'm creating a lot of indexes there, but you need to create only the indexes that you need, because when you do some DMLs on insert, deletes, update, those indexes will be updated. And we are consistent, they are updated consistently. And then the more you have, the more activity you have. And to show that, I will add a new country. And we have no country at latitude, longitude 0, but I will create one. And the interesting thing is that I'm creating a null island, but I didn't invent it. You can Google for it. You will find a map and picture of it. There is a Wikipedia page about the null island at latitude 0 and longitude 0. But what I wanted to show here is that an insert there, if I look at the statistic, the insert had to go, of course, into the table to insert the row, but update also the the related index entries. And I have created 4 indexes, and then it needs to maintain those 4 indexes. And in addition to that, we have a foreign key to another table. So all that is a distributed transaction between multiple tablets. But again, the complexity depends on the complexity of the schema, the number of indexes, the number of foreign keys. But adding more node will not add more work in there. So it still scales. You just need to balance between the complexity of the schema that you need for your application and the performance.
Awesome. All right, folks, I think we're 2 minutes over. This was a fantastic session. I think the takeaway for me here is we need a follow-up session to do even more stuff like that. The region example that you were showing, Franck, it'd be very easy to show it with table spaces and answer the question about picking the local indexes also. So we can kind of build it towards that, which is awesome. But once again, thank you folks for attending. This was really interactive, really good, really fun session. I enjoyed it. I'm sure Franck did too.
I'm going just to the last slide to show the Slack channel.
Yeah, join us on Slack, yugabyte.com/Slack, and obviously start us on GitHub. We love that. We have our distributed SQL Summit Asia coming up next week. Join us there, and keep continuing the conversation on Slack. We're here to answer your questions. Thank you, everybody. See you next week.
Thanks a lot, and thanks for all the questions. Bye.
Bye.